Okay, yes, thank you. So sorry, I don't speak Greek, so I will stick to English. Yes, so I'm representing CSC, the IT Center for Science in Finland, and I will talk about training large language models on LUMI. As was mentioned in one of the previous presentations, the fastest supercomputer in Europe. So this slide just shows the LUMI consortium countries. So you can see they're marked in the map. So these are the main consortium countries behind LUMI, but as you can see, the resource allocation, so it also goes through the EuroHPC, so any EuroCC country can apply for resources there. So it's not only the consortium countries. So for example, researchers from Greece can also via the EuroHPC can apply for resources. So LUMI is hosted by a Finnish supercomputer center. You can see the small dot there in the middle of Finland. That's the city of Kajaani, where the supercomputer is located physically. And the support for the supercomputer comes from all the consortium countries via the LUMI user support. And also the local, each country also have their own local support. And one thing interesting also that we can have up to 20% of industry usage as well. So companies can also apply for access. So the LUMI supercomputer, there you can see a picture of it. It's a HPE Cray supercomputer. It has about 2000 CPU nodes. You can see all the specs there. I will not read through all of them. And then we have almost 3000 GPU servers, and the GPU ones are, of course, the one where we get the biggest compute from the GPU side. So especially interesting here is that each GPU node has 4 AMD MI250X GPUs. So this is of course unusual because we are not using NVIDIA GPUs, but AMD ones. I will talk a little bit more about that later. And from the user's point of view, this MI250X card is actually 2 compute dies, so it's basically like two GPUs kind of glued together. So for a user, it looks like there are 8 GPUs per node. So one node in LUMI is already for many users quite fast in itself. So so this is another picture of a single node. So you can see here the 4 cards, each with the two GPU chips. So marked here with the GCD and the number. So here would be the 8 GCDs or GPUs. And each of those GCDs has 64 GB of GPU memory and quite fast performance. And then, so you can say, of course, that it's not that huge amount of memory. There are other providers have larger one than 64. But the nice thing in LUMI is that we have really a lot of them. So almost 24,000 of GCDs. So that's quite a huge resource, and the reason for LUMI being the fastest in Europe. So as I mentioned, we are using AMD GPUs. That means that if you are familiar with NVIDIA GPUs, there you use the CUDA software stack, and AMD has the ROCm stack. And they have provided nice tools so you can convert your CUDA code to this Heapify tool, so that solves many problems. And in particular for large language models, they are basically almost exclusively using Python and PyTorch, and that's pretty well supported out of the box. I have here a screenshot from a tweet where the AMD and PyTorch announced that they will work together to get it working well on AMD. Of course, there are still some issues and some edge cases. Of course, and the large language model and AI arena is moving so fast that there are always new things. And typically the new things work first on NVIDIA, but AMD has been pretty active in porting things to AMD as well. Things like flash attention, bits and bytes library was at some point asked by many users. VLLM is used for inference, so on. And these have all been or are being converted by AMD as well. And we have sometimes seen some strange issues, but then we have been in contact with AMD and some solutions have been found. So you can say that it's not as easy as with the NVIDIA stack. Of course, NVIDIA has had longer time in the area to work on these things, but usually we have found a solution, and it's been quite nice. This slide shows a few of the news items. I guess one of them in Finnish, but two others in English, about large language models being trained on LUMI. So we have the Finnish one, Poro, which I will talk a bit more about in the next slides. But there are also other ones, for example, the English open model, Olmo, by the Allen Institute for AI. And also a nice thing about LUMI is that the fact that you can see here from the Olmo paper, they report almost zero carbon emissions because LUMI is using hydropower, and it's also reusing, so it's liquid cooled, and the heated up liquid is used for district heating in the city of Kajaani. So there are some environmental benefits there. So the Poro is the Finnish large language model that has been trained on LUMI. And of course, English has already very good support in many of the large language models, but small local languages, for example, like Finnish or maybe Greek as well, although I would say that Finnish is maybe even smaller, one doesn't have quite as good support. So that's one reason for researchers in Finland being keen on creating such models. So this one is the 34 billion parameter model. It has been trained on 1 trillion tokens. And here token is word or word parts. And the main driving here has been the research group at University of Turku, which is one of the university towns in Finland. And they have been working together with Silo AI, which is, I think, the largest Finnish AI company. Might be also quite large in European scale. At least they advertise that they have more than 150 PhDs employed there. In fact, many of my old friends from university are working there. And then CSC, my employer, helped out with the technical challenges as well in this project. And in fact, Väinö Hatanpää, who is mentioned here in the paper, He was my colleague who worked very closely with them in the key stages of getting it working. I have a few slides. These are borrowed from Professor Sampo Pyysalo from the University of Turku, which shows about the training data. So one problem with Finnish is that there is actually not enough training data. They want to have good quality, clean training data, and there just isn't that much data available online in Finnish. So they did things like resampling of the data, so to get kind of the proportion of Finnish to be larger than what it would normally be. They also used English language data, as you can see, and also programming code as a kind of a language for the training. And they did some evaluation. They have their own quite comprehensive FinBench benchmark, which tests many different language tasks with this model, and it was substantial advance over previous models that were trained also by the same group. And you can see also it's competitive with other large models which are not trained for Finnish. And also testing English-Finnish translation. And you can see, for example, compared to ChatGPT or GPT-4, it's quite competitive, better or roughly equal. Of course, those models are much larger. This is one caveat, is that this is for single sentence translation, as is done in those benchmarks. So I guess the speaker, not the previous one, but the one before that, talked quite a bit and in more technical detail about training. The one big challenge here is that these large language models are so large that they don't fit into the GPU memory. As I mentioned, the LUMI single GPU or GCD GPU chip has 64 gigabyte of video memory or GPU memory. And if you have a model that's, for example, 140 billion parameters, you can calculate, assuming a 16-bit model, it would take about 280 gigabyte of RAM. Then you would need 4 GCDs. And even the Poro model, which isn't quite as big, it still doesn't fit into one GPU. I think it needs 2 GPUs. So there are many ways of splitting things up across tensors and across the pipeline. And then also for the training, there are the gradients and optimizer states that have to be somehow shared among these. So it was also mentioned previously the Accelerate library, and there is also the PyTorch fully sharded data parallel. These work quite well up to a point, but then these really large scale runs that you are training a language model from scratch are a bit more difficult. So in Poro, they use this Megatron LM model, and that had some problems because at some point it was very tightly integrated to NVIDIA. So the people working on Poro model, they actually took a very specific commit from Git and then made some of their own tweaks with the help of my colleague from CSC. I see the background is incorrect here, but you can still see the pictures here, some of the challenges. The picture here on the left shows that it's quite important to have the right drivers for the communication. So the red one here, we are using the faster driver to really get the speed out of the slingshot network. But even here, it's not a linear scaling, which was what the user expected from the start. And if you look more closely how these pipelines work, it's actually the fact that you cannot do linear scaling, even though you would have perfect communication. So the problem is that the model is split over many GPUs. So the top right image shows when you are doing the forward pass, you have to go through each of the GPUs, and then for the backward pass again through the GPUs, and then they are always waiting for the results from the previous step. This can be alleviated, as you can see on the right in the bottom, by splitting up the batches even smaller, so that while you are waiting for the next images, you can already start processing the next one. So, but however you split them up, there will always be these areas of waiting, which are called a bubble. So you can never get to perfect linear scaling just from the fact of how the processing pipeline works. These are some examples created by my colleague that scaling, when you get everything set up right, still works pretty well. So on the
Mats, if you
yes.
could wrap up in a couple of minutes, that would be great.
Yes, I'm just at the very last slide. So, and here the strong scaling on the left means that we are indeed scaling the same kind of process, while weak scaling we are enlarging the batch size, so that makes it a bit easier and not so realistic. Okay, so as a conclusion, the LUMI supercomputer works quite well for large-scale pre-training, that is training even from scratch of these large language models. And you can say that then it gives also us academics a way of competing with the huge American companies. And this Poro was one case where was collaboration between academia and a company, and then the supercomputing center was also central here in getting everything working. And there I have some links to other models. Most recently, the Viking model, which also has other Nordic languages in addition to Finnish. Okay, sorry for going a bit over time.